In this short video, we'll look at how you fit curves to graphs in Excel. This is a great thing to know how to do if you want to make a linear fit or an exponential fit or a different kind of fit to a set of data that you have. It's also a great thing to know if you then want to take that equation that's generated automatically by Excel and then use that to make projections into the future. So this will be a short video, but we'll just go through the process of how you make that fitting process happen in Excel. So we're going to work through a small and pretty simple data set. This is actually the data on COVID positive numbers for the United States since the first case that was found back in February. So what you're looking at in this data basically is day one, the first day when cases were found in the US. There were 2 cases that were positive. By day 9, there were 3. By day 15, there were 8, and so on up to the present. This was for August 21st, 2020. There were 5,546,497 COVID positive cases in the United States. All right, so what we want to do is actually see what this looks like in a graph and then fit a curve to this so that we can approximate the type of growth that is happening in this particular data set. So I'm going to select the data that I want to graph. You can see I've done all of that. And then go Insert, and we're back to the XY scatter plots again. The reason again we use XY is because we have 2 continuous variables, one on the x-axis, one on the y-axis. We need to use an XY scatter for that. So I'll just pick one of the options. There's our graph. I'm going to move it all the way up to the top so we can look at it up here. All right, so we have a curve now. What's neat about Excel is that we have different ways of fitting different types of curves to this graph. So let's look at those. I'm going to take my cursor, if you can see that. I'm going to click on the data line, and then I'm going to right click or double click depending on what you're using. You're going to get a pop-up menu. On that pop-up menu, it says Add Trend Line. So I'm going to select that. And now what you see is I've got a bunch of different options. The default's going to be a linear fit, right? So this is a y equals mx plus b, right? The y value is equal to the slope times the x value plus an intercept that's calculated. In this case, it would be negative. You can see with your eye that this is not a particularly good fit. The curve starts out slower and gets faster. So something's off right here. In fact, let's go ahead and do this. Down at the bottom of this dialog box on the right, there is a selection for display equation on chart and display the r² value on the chart. Move these out, make this a little bigger. So what you're looking at right now is the slope, that y equals mx plus b. So the slope would be the 25,814. And in fact, what that's saying, because x is a day, is that each day in the United States, on average, using a linear fit, from the start of the COVID crisis, we've added 25,814 cases. The intercept here, which you have to subtract off that line, is this number of about negative 1 million. It's negative because this line is not a good approximation of the curve. The r², which is a measure of what's called goodness of fit, it's a measure that takes into account the average difference between the actual point and the point that is represented on the line. So say at day 100, there's a difference between the actual data and the line data point that's projected. Take those differences, we square them, put it into that equation. And r² of 1 is a perfect fit, and r² of 0 is a horrible fit. And a rough kind of rule of thumb is that r² tells you basically what fraction of the data are captured by the line. So in this case, it's about 89%, which actually isn't too bad, but you can see that it doesn't look too great. All right, so back to the trend line. Get out of the label. I'm going to go back to, actually I'm going to delete that trend line, and let's do this again. You can see it one more time. Add trend line. All right, so now let's try some different things. You might say, oh, well, this kind of looks exponential. Well, it doesn't fit a simple exponential very well. Logarithmic is one that levels off. Unfortunately for us at the moment in August 21st, 2020, it does not look logarithmic. This is what you would hope it would look like. This is what it looks like in Europe. It does not in the US. The ones that tend to fit best, because they're a little bit more complicated, are going to be a polynomial or a power. You can see in this case the polynomial fits very nicely. We can do the same thing. We can get the r squared. You see that r squared is 0.9933. It's an almost perfect fit. And then here's the equation. Just to walk through this so you understand what's happening, it says that the y value at any point in time is equal to 157.08 times the x value, or days, squared, minus 7644.4 times the x value, plus, again, an intercept of 64277. That yields a very good fit right here. So that's really all there is to curve fitting in Excel. Now, the reason you might want to do this is because you could then project things forward into the future. If you think you have a trend line that is a good representation of data, you can then project it forward. So if I wanted to say, what is the y value likely to be on day 1,000? 1,000 days, almost 3 years after the onset of this crisis, the answer would be 157.08 times 1,000 squared, that's your x value, minus 7644.4 times 1,000, again your x value, plus 64277. That will tell you, given this fit, what you're looking at projected for day 1,000. So really nice feature of Excel, really nice way to quickly look at data and look at trends and understand the shape and the dynamics of these sorts of patterns.